AC through RC circuit, understanding phase shift. Hi friends. Today, let's explore how alternating current, or AC, behaves when it passes through a resistor-capacitor circuit, also known as an RC circuit. We will understand how resistance and capacitance affect the current, voltage, and most importantly, how a phase shift is introduced in the circuit. So, let's get started. Circuit overview. We have a simple series RC circuit where a resistor, R, and a capacitor, C, are connected in series. An AC voltage source is applied across the circuit. We will analyze how current and voltage behave. Now, let's break it down step by step. How AC flows through the circuit. When we apply alternating current, the voltage is constantly changing between positive and negative. Now, how does each component behave? 1. Behavior of the resistor. The resistor, R, opposes the flow of current, but it does not cause any phase shift. The voltage and current across the resistor are always in phase. This means that whenever the voltage across the resistor reaches a peak, the current also reaches its peak at the same time. 2. Behavior of the capacitor. The capacitor, C, does something different. It stores and releases charge as the AC voltage changes. This introduces a phase shift between voltage and current. In a purely capacitive circuit, the current leads the voltage by 90 degrees. This means the current reaches its peak before the voltage does. But since we have both a resistor and a capacitor, the phase shift will be somewhere between 0 and 90 degrees, depending on the values of R and C. Understanding the phase shift. Now, let's focus on the most important part, phase shift. In an RC circuit, the voltage across the capacitor lags behind the current, meaning the current reaches its peak first. Then, after some time, the voltage across the capacitor reaches its peak. The amount of phase shift, denoted as theta, depends on the resistance and capacitance and is given by the formula. Theta is equal to inverse tangent of 1 over 2 pi FRC. Here, F is the frequency of the AC signal, R is the resistance in ohms, C is the capacitance in farads. For high frequencies, the capacitor has low reactance, meaning it allows more current to pass, and the phase shift is small. For low frequencies, the capacitor has high reactance, meaning it blocks current more, and the phase shift is larger. Real-world applications. This RC circuit behavior is used in many practical applications, such as signal filtering in audio circuits, phase shifting networks in oscillators, timing circuits in microcontrollers. Summary. The resistor does not introduce phase shift, but the capacitor does. Current leads voltage in a capacitive circuit. Phase shift depends on frequency and is calculated using theta equals inverse tangent of 1 over 2 pi FRC. So friends, that's how an AC signal behaves in an RC circuit and why phase shift occurs. See you in the next session.